Welcome to this video on two-way tables, probability, and the general addition rule, Venn diagrams, and probability. We have a lot going on today. By the end of this video, you should be able to apply the general addition rule to calculate probabilities, and you should be able to use a two-way table or Venn diagram to model a chance process and calculate probabilities involving two events. All right, so we had, can you taco tongue or evil eyebrow? So evil eyebrow is where you can raise one eyebrow but not the other, as good evil doers in movies can do. And taco tongue is, can you curl your tongue into a taco shell shape? So we collected some data within a class, and let's see what we've got here. We've got 10 people who could do a taco tongue and an evil eyebrow. There were 2 people who could do the evil eyebrow but could not do a taco tongue. There were 18 people who could do a taco tongue but could not do an evil eyebrow. And there was 1 person who was unable to do either of these things. So for our two-way table, we want to go ahead and get our totals because we're going to need those as part of our answering. When we take a look, these should both add to the same number going both directions, and they do. We had a total of 31 students that we collected data from. So what I want you to do is I want you to pause the video, and I want you to go through and I want you to answer all of the questions all the way to the bottom of the page on your own, and then come back. We'll go through them and get some concepts and see how you did. All right, pause the video here and come back when you're done. All right, so for question 2, we just were randomly choosing a student from the class to determine these probabilities. So the probability of yes taco tongue, so that would be the total of taco tongues divided by your total, the 28 out of 31. No taco tongue, same thing, 3 out of 31. Yes taco tongue and yes evil eyebrow is where these two cross, so that'd be the 10 out of 31. Yes taco tongue and no evil eyebrow is where these two categories cross. That's the 18, so 18 out of 31. Yes evil eyebrow is just the total here. That's a marginal frequency, 12 out of 31. No evil eyebrow, 19 out of 31. Yes evil eyebrow and no taco tongue, it's where the two categories cross at 2 out of 31, and then no taco tongue and no evil eyebrow is 1 out of 31. So hopefully that was pretty simple. You didn't have any problems with that. So then we went through, and suppose we randomly choose a student and we're going to find the following probabilities. And we actually answered these already. Yes evil eyebrow was 12 out of 31. No evil eyebrow was 19 out of 31. And then yes evil eyebrow, or remember that or means plus, no evil eyebrow. So yes evil eyebrow plus no evil eyebrow equals the probability of them together, which is 1, because that was everybody in the class. Okay, so now let's take a look at number 4. So 4, what's the probability of yes taco tongue? We had 28 out of 30. Sorry, 31. And then we had yes evil eyebrow, which was 12 out of 31. And then yes taco tongue or evil eyebrow. Good. So we'll add them just like we did before. So we have 28 out of 31 plus 12 out of 31. Hold on a second. That's 40 out of 31. We can't possibly have more people than we have people. There's only 31 people. How could we possibly have gotten 40? Well, let's take a visit back up here to our two-way table to kind of help us with this. So we said yes taco tongue. All right, so yes taco tongue is going to be this category right here. And then we also said yes evil eyebrow. So that's going to be this category right there. What has happened is these 10 people right there, they were counted in both categories. We counted them twice. So we don't want to represent people twice. What we want to do is we want to subtract off the overlap of those 10 people because they were counted twice and they shouldn't have been. And that will give us a total of 30 out of 31. So why is that? Why did we in this one not have to subtract anything off? But in here we had people that were counted twice. Let me show you. It's because one group was mutually exclusive and one group was not. So number 3, for evil, you were evil eyebrow or you were not evil eyebrow. They did not share any outcomes in common. And in a two-way table, they're parallel to each other so they don't cross. They don't share anything in common. So number 3, these are mutually exclusive events. Okay, they don't share any outcomes in common. And it's pretty easy to see when you look at the table that they're side by side. Same with taco tongue and no taco tongue. They are parallel to each other. They'll never cross. So they share no outcomes in common. So they are also mutually exclusive. However, when I asked about the taco tongue and the evil eyebrow, we had taco tongue and we had evil eyebrow. We had this crossover. Anytime the categories cross like that, they're going to share outcomes. In this case, they shared these same 10 people. So they were counted going in one direction and in the other direction. And that's why we had to subtract them off over here. So we didn't count, we were counting the same people twice, and we can't do that. So these two topics are not mutually exclusive events. All right. So let's look at what this looks like in probability. So in the previous lesson, we learned about the general addition rule, and I said a couple times specifically for mutually exclusive events. So we said here the probability of A or B equals the probability of A plus the probability of B. Okay, because they share nothing in common, we can just add them together. It's no problem. Okay, however, for the general addition rule for not mutually exclusive events is we start off the same. We're still asking the same thing, the probability of A or B. And we still did the same thing. We took the probability of A and we added it to the probability of B. However, we had to subtract off where they occurred together. These 10 people is where it was both of them together. I had yes, and yes. So we're going to subtract off the probability of A and B. That's where they cross in their two-way table, where they share their outcomes in common. Okay, so they're essentially the same. It's just if you have not mutually exclusive events, you need to remember to subtract off the overlap. All right, so the other part of your notes here on the front is we have a Venn diagram right up here at the top. This is a Venn diagram. It is a type of sample space. We had sample spaces in previous videos where you listed all the outcomes. All right, so a two-way table and a Venn diagram are buddies. They represent the same information. So I'm going to call this one the left-hand Pac-Man because he's kind of like a Pac-Man and he's on the left. This is going to be our right-hand Pac-Man. And this is the football in the middle where they all come together. So I have yes, taco tongue, yes, evil eyebrow. So I'm going to take my information from my table and get it in here. I like to start in the middle because that makes the most sense to me. this football section right here, football shaped section, is yes, taco tongue, and yes, evil eyebrow. It's those 10 people that are in both categories. Okay, so I'm going to just draw an arrow to say it's going to go right over here. Okay, now we have people that are just yes, taco tongue. So that means yes, taco tongue, and no to the evil eyebrow. So that's this number right here. That's the 18. So together, you can see we have the 28 total. We're just kind of dividing them by what they represent. Okay. Over here on my right Pac-Man, I have yes, evil eyebrow only. That's all that's represented in this one. So that means no taco tongue. So yes, evil eyebrow, and no taco tongue. So that's going to be 2 for this information. And then I have people who aren't represented at all on here, and that's going to be what goes on the outside. You don't want to ignore people. If they're all part of the sample space, we were specifically asking about these scenarios. Anybody that doesn't meet that scenario is going to go on the outside. I call this like the placemat because it looks like dishes on a placemat. And we had one person who couldn't do either, and so they're going to go right there. Right? So your Venn diagram is the same as a two-way table, and you can take the information from one and put it in the other, or work backwards and make it go the other way. All right, let's summarize our notes and see how we're doing. All right, we're going to start off talking about our two-way tables and our Venn diagrams. Go ahead and pause the video and copy that part down so we can start filling it in. All right, so in our two-way table, I'm going to label these that we have event A and we have event B. Okay. The other category, so we have A, so this is also part of the A event, but really it's not A, or the A complement. So we have A and not A. So we have B, and this will be not B. Okay. Where A and B, so if we're talking about probability of events A and B, that's where they both occur together. If we look on our table, they both occur together right there. That's what we were talking about, where they share outcomes in common. Okay, so I'm going to do a little color coding here to see if that helps a little bit. This column, this box, represents the football shape in the middle. All right, then we have the probability of event A, but not event B, or the B complement. So that means A only. This left-hand Pac-Man is A only. So I'm going to put my 2 in there. So just so I know kind of how the numbers relate to each other. Then I have event B and not A. So that's B only is what that's saying. So when I look at this, I've got event B in the right-hand Pac-Man, and there's no A in it. As long as I don't go into this part of the circle, that includes A. So I'm going to stay outside of that part of the circle. So that's B only right there. All right. Forgot to color in my pink, so we'll just add that in now. So we kind of have a color representation to help us. All right. And then I had a category that didn't belong to either of these circles of not A and not B. And that goes on the outside. The numbers have to add up to the total when you do this. So just be real careful not to forget the people who aren't included in that scenario. Okay, so this is going to be the sample space around the placemat. And then that's going to represent that right-hand Pac-Man. All right, the other thing I wanted to do is bring together our two discussions on the general addition rule. So today when we talked about not mutually exclusive events, so not mutually exclusive, we have to remember there's people in both categories that we're adding together. So we have to remember to subtract off any overlap. So if we had for not mutually exclusive, we had the probability of A or B equals, we're going to take their probabilities and add them together, but we're going to subtract off where they intersect because we already counted those people in one of them. We don't want to count them twice. So we're going to subtract off the overlap. Now, if we're talking about mutually exclusive events, so if A and B are mutually exclusive, so if they're mutually exclusive, then the probability of them occurring together, if they're mutually exclusive and the probability of them happening together is 0, since they cannot occur together. All right, so that's where you run into the shortened version of the general addition rule. The probability of A or B will just be the probability of A plus the probability of B, because there will be no overlap to subtract off. All right, what I'd like you to do is try the check your understanding. Please pause the video, try it on your own, and come back and see how you did. All right, so whenever you get a table, make sure you go ahead and add everything up and get your totals. It'll make everything a whole lot easier. So explain in plain language why the probability of over complement means and find its probability. So the probability of over complement is the probability of choosing a student who does not prefer the toilet paper over the top. Okay, so you have, if you have a roll of toilet paper, you have that the loose sheet can be over the top, or you have that the loose sheet can be coming underneath. That's really what it's saying, okay? People to have a preference. So to find the probability of not over the top, so I look over here, this is over the top, I have not, there was 46 people, so 46 out of the total 116, so when I reduce it down, 0.397. Okay, so then I ask you in part B, why does the probability of O or R not equal the probability of O plus the probability of R? And then I want you to find the probability of O or R. So the probability of O or R does not equal the probability of O plus the probability of R because the events over the roll and replace when empty are not mutually exclusive. So if we look up at our table here, we have over, which is this category. And then we have replace, which is this category, and they crossed. Anytime they cross like that, they share outcomes in common, so they're not mutually exclusive. So I showed my math out the long way, so you could see everything. So if you just ended up with the fraction and the probability here, that's fine. You didn't necessarily have to show me all of this, but I wanted to show it the long way so you understood where all the numbers came from. So I had the probability of O, which is 70 over 116, plus the probability of R, which is 82 over 16, but I crossed that 58 twice. I counted it twice, but they're the same people, so I have to subtract off those 58 people. So I got 94 over 116, which equals 0.810. All right, and then our Venn diagram, we had an over circle and a replace circle. So I like to start in the middle. That's the one that makes the most sense to me. Where they occur together, over and replace. Over and replace is right there. That's at 58 people. Okay, this is over only and no replace. This is over only and no replace, so that's those 12 people. This is replace only and no over, so that's those 24 people. And these people don't do either of these, so they go out on our little placemat on the outside edge. So if I added these all up, I'll end up at my 116 students. All right, and then our last one. Write the event does not replace the roll and prefers the toilet paper pulls over the roll in symbolic form and find the probability. So the probability of does not replace would be replace complement, so not replace, and over the top. Okay, so we have replace complement and over the top is those 12 people or these 12 people. They represent the same thing out of the 116, which will equal 0.103. All right, hopefully that was helpful. Let me know if you have any questions. See you in class.